Hi, so we're going to go through how to use the software programs that are designed to run the Q Exactive Plus and the associated LC, which is the Ultimate 3000. And so there's two separate software programs that are used, but that are connected to one another for doing this. And so this is showing you the desktop of the computer that runs the mass spec in Baker 464. And so the two programs that are going to be important, the first one is called Tune, which is responsible for running the Q Exactive Plus by itself. And so this allows you to have manual control over the instrument to change various parameters to just run things as is, but it doesn't allow you, it actually does, but I don't know how to do it, allows you to actually record data in this program and your spectra. The other program, which runs both the mass spec and the Ultimate 3000, so the LC component, is what's known as Excalibur. And Excalibur is a program that's offered through Thermo that has multiple different components of it. And so this allows you to set your instrument methods to actually run a gradient. It allows you control of the LC manually, similar to the way that Tune lets you control the MS. And you can also use different tabs in this program to look at your raw spectra and analyze it. So we're going to do a couple of videos showing how these various software programs work and kind of the components that they have in it. So we're going to start with a Tune file, which is the mass spec. And so when you open this up, let's try to get this full screen. You'll notice that there are a bunch of different buttons up here. And so starting at the top, you have your normal toolbar, which allows you to select different tune files. And tune files basically are just a set list of parameters that you can change depending if you want to run different modes. So let's say you want to look at the MS of something, but you want to use negative polarity. You can change a different or save a different tune file that will have all of your set parameters in that you can load instead of having to manually go through and set them all the time. Alternatively, because we have two separate heads, we have the NanoFlex and the heated electron spray ionization head, which are how the sample actually gets injected into the machine. Those have separate parameters that need to be changed. And so you can load different tune files just to quickly transition between the two of them. And then you can see right here, there's a data log and various different reports that you have, like in terms of calibration and all of that get saved up here. If you click on help, it'll open up the user manual. And then the Windows just allows you to change what you can see in this. This button right here, the general instrument state, allows you to turn the instrument on, in standby, or off. The instrument should never be placed in off unless you're doing maintenance on it. And so when you turn the instrument into off mode, what happens is you're breaking the vacuum seal. And to get the instrument operational again, you have to go through a bakeout period where essentially you're putting the instrument under very high temperatures to reestablish that vacuum, and it takes about 18 hours. When you break vacuum, you also increase the risk that something is going to happen in all of the tiny little pieces that sit inside the mass spec. And so never turn it to off unless you are absolutely sure that you need to turn it to off, which you probably never do. If you are not running the instrument, if it's in standby, which is shown, so you can see you have on, off, or standby, it's basically sitting idle, but the vacuum is still there. And then if you were to turn it on, which I'll show you in just a second, it will actually start analyzing anything that you're spraying into the instrument. If you need to open a tune file, this is just a shortcut to do it. If you're going to save something, again, a shortcut to do it. There are options to change the divert valves. In the environmental proteomics lab, we do not use these because we're using the LC component. And so if you were trying to inject large volumes, from different samples into the instrument, this is something that you would use. But again, basically, we don't have them in line, and they're not important. This little button is important specifically for calibration. And so when we're calibrating the instrument, we have a CalMix that's applied by Thermo Fisher that we inject into the instrument. So this is actually a partial spectrum from that CalMix. It's a composure of like caffeine and a couple of other different, like acetic acid, I believe, is in there. So this has a automatic syringe pump controller where we can adjust the flow rate into the machine and tell it how much we want to be pumped in at any given time. And then, so if I were to click on this, so I can change the syringe type. The type we have is a Hamilton. It holds 500 microliters, and then the flow rate right now is set for 10 microliters per minute. You can change this, and then I can stop and start the syringe here. I have never used the direct instrument control, this little thingy, and so I don't know what it does. You probably will not need it. The other important part of this toolbar up here are these 3 different lights. And these basically tell you the status of the instrument. And so ideally when you're running the instrument, you would want to have all 3 green lights. If you have a red light, it will shut the instrument into standby mode because it means that there's something wrong. I mean into off mode because there's something wrong with the instrument. So this first one is communication state. And so there are HDMI cables and USB cables that are directly connecting the MS to this computer. And so if one of those gets unplugged, you can no longer control the instrument. It will tell you that the instrument status is lost, and it will sometimes shut the machine off. I've had it happen where you've had issues with this, and sometimes if you just restart the computer, everything will go back to normal, or sometimes it's necessary to restart the electronics on the mass spec, which I'll go through in later videos. But again, this is just kind of something you'll have to learn as you go along with. This usually is always green. Hardware state is basically that you have no problems detected. And we'll go through these side panels, but typically the most common one where you have issues is the vacuum system. And so our vacuum relies on a nitrogen generator from house air that's being pumped into the building. And oftentimes the house air gets turned off either because of problems in the building or because of routine maintenance. And when this happens, we lose vacuum. If there's something really wrong with the instrument as well, you can lose vacuum. And so this will turn to red and automatically the instrument shuts itself off. This last one is performance state, and this is basically telling you the status of your calibration. And you can see right now that my mass calibration for the positive mode, the last time I did this was on April 3rd. And so typically we calibrate the instrument once a week. The settings on here right now, after 24 hours, it tells you that the instrument's no longer calibrated. It's fine for a week. And if you're not running it, you should calibrate it every week, but if it goes a little bit longer, that's fine. In terms of the different windows we have here, so all of these, I don't think I can collapse this one. So we have instrument control, mass traces, calibrate, evaluate, and vacuum or bake out. These allow us to control different components of the instrument, and you can change them. So for right now, we have this set. So the scan type is doing a full MS, which means it's looking at the full mass spectra of everything that's being shot into the instrument. So basically, this is showing you the relative abundance. So this is kind of like our total ion chromatogram. So it's the abundance of ions for any M over Z that are being injected into the instrument at any given moment. The scan range tells you what this x-axis is going to be. So we have it set right now from 150 to 2000 M over Z. When we're running our proteomic samples, typically we set it to like 400 to 1600 because that's the range where we have proteins. We're not looking at fragmentation typically when we're just running this, because oftentimes if you're manually controlling this, the reasons for that is either to calibrate the instrument or when you're putting a sample on, to just make sure that your spray is stable before you actually start running your method. And so this is just kind of a way for you to like look at the overall status of the instrument and the health of it before you start processing your samples. We don't really change any of these parameters. We do when we're running an actual method, and I'll go through how that is, but basically our tune file that we have loaded, the one that's loaded right now is actually for the calibration. If you have your resolution of 140,000, our polarity is positive. We're doing 1 microscan, lock masses are off. Our AGC target is our automatic gain control. And so basically this is the number of ions that you want injected into the Orbitrap if you were doing fragmentation. And then your injection time is going to be 30 milliseconds. You can change all of these. But like I said, typically these are already going to be set in the couple of tune files that we have loaded. And unless you're doing something completely different, you'll have to do a lot of like research on which of these parameters you'll want to change. In terms of the source, so we have 2 different sources that I talked about. So there's a Hesse source and a nano source that allow you to inject ions into the instrument. One of them has a much higher flow rate, which is the Hesse source. So this is the heated electro spray ionization. And this is the one that we use when we are doing calibration. And so this would be if you're have really large volumes, you're just spraying a bunch of stuff in. Because you're spraying in larger volumes, it uses gases to help kind of funnel things in correctly. And so there's 3 different sources of gas that come in off of this head. If you want to know more about this, you can read through it in the actual like Hesse source information. But you have the sheath gas flow, the aux gas flow, and the sweep gas flow. And so you can change these different parameters to manipulate how much air is being blown in. Occasionally I'll change these when I'm trying to calibrate if something gets clogged in there to just go to higher gas rates. Basically, we're trying to like burn off everything that's in the instrument. But when you're actually doing the calibration, this is what you want set at. One thing that's really, really, really important is the spray voltage. So you oftentimes will be changing the spray voltage. Using the Hesse source, having a higher spray voltage like 3.7 kilovolts is fine. When you're running nano spray, you want to have a much lower spray voltage, like 2.5, I think is the maximum. And depending on your sample, you may even want to lower that. So if you have too high of a spray voltage, you can actually cause an electrical current between the needle and the instrument, and you can like burn stuff up, which is bad. The capillary temp, we also change. And so one of the things I'll go over is how to change the ion transfer tube, which is the tiny little tube that the sample gets injected in. And you actually have to remove that from the instrument. When you do that, you don't want to have the temperature of that at 320 degrees. 1, because it's metal and it would bend, but 2, also because it increases the chance that you would burn yourself. And so if you were going to do that, one thing you would do is just change the temperature down to 100. You'll notice when I type this in that nothing's actually happened yet. And so for this program has it built in kind of as like a safe point where you have to actually say you want to do something, and then it's going to basically be like, are you sure? And you have to hit apply, right? And so what I've done now is I'm going to slowly lower the temperature of this capillary temperature, which basically is like where the source actually gets or sends the sample into the instrument. This hot link button allows you to make changes without having to go through that second apply step. And so if I turn it back to 320, it'll go back up. We never change the RF level of the lens. You can if you're getting bad signal, but if you're getting bad signal, it's probably because there's something else wrong with the instrument and not the, so this is the radio frequency of the S lens, which again, I'll show you a diagram of all of these. And then you have the auxiliary gas heater temperature, which is for the auxiliary gas flow rate. For what we do in our lab, none of these parameters are necessary. If you were using different types of probes or different types of needles, so like a glass capillary has to be heated, or depending on different applications that you're doing, these would be important to change. But for our purposes, you will never need to do these. So this is more just explaining it. And then the last part of this is just this acquisition status. This is kind of reading stuff. So you can see the last thing I ran was one of our students was looking at seal proteomics. And so this is kind of communicating with that other Excalibur program and talking about what was happening. So again, this is just kind of giving you a status of what happened the last time. Under this mass traces tab, so first of all, let's go really quickly. So I have this set up so that normally we keep this at 5 microliters. So I have it set up so that right now the HESI head is on, so it's ready for calibration. So if I go in and load a tune file, you'll notice that there are all of these tune files saved. The HESI calibration tune is for the positive ion mode calibration. And then there's a negative calibration tune if you were going to do this in negative mode. And then these other ones are various tune files that we use when operating the instrument. So I want to make sure that the HESI calibration tune is loaded, which it should be. So it has all of these parameters that are appropriate to the ion source. And then if I go and turn the mass back on, right now I'm not getting any signal, which means nothing's being injected into the instrument yet, because I turned the flow on and it hasn't gotten there. As you start to see these peaks show up, what's happening right now is a bunch of crap, basically. And so you have your scan parameters up here. So this is the number of scans it's taken, what the injection time is, how many microseconds. So a lot of this was set over here. Basically, this is just a summary of the parameters we have. And then you have your resolution, your M over Z, and then the actual Z. So you can see a lot of this is 1. This is basically just junk that's being burned off the instrument because it's been sitting idle for a long time. So stuff like crud and plastics and stuff that are in the room burn off. So as this starts to stabilize, we'll actually be able to see what it looks like when we have that calibration mix going. On this side for instrument status, while we're letting this stabilize, let's talk through this. So since we have this on, you can see that there's current scan. And so the total ion current tells you how many ions per second are being injected into the instrument. And this is changing all of the time. TIC variation is your total ion current variation. And you can see that this is a percentage of how much that's varying. That is extremely important when you're trying to determine the stability of your spray. And so if you're going to run a sample, you can tell if your spray is stable because the TIC variation should always be under 10%. And so if you have everything hooked up, and let's just say you're spraying through your column, water and formic acid into it, and no sample with a little bit of acetonitrile, you'll see this very stable pattern of basically it's the chromatogram from acetonitrile. And there shouldn't be any variation in the ions that are being sprayed in because you have this really stable stream. All of your parameters are set correctly. Everything's positioned in the right order so that ions are just continuously being sprayed. If you get lots of variation, that either means that there's something in there that's clogging it, that's causing the ions to not come out in a steady flow, or that for some reason your spray voltage is losing signal. And we'll go through that a little bit more, but this is going to be related to this next mass traces tab that we go through. Again, this tells you your ion inject time, that you're reaching your target of how many ions are going into that Orbitrap, and your scan rate. Okay, so this is something that I always have open and I'm always looking at because this tells you how well ions are being injected into the instrument. In terms of these other tabs, you as a standard user will never have to worry about them. And you can see right now I'm actually in the advanced role user. These are more for when the technicians are out and are using these various different tabs to look at the function of the electronics. the performance status mostly just is whether or not it's calibrated, but it will tell you different variables. So you can go through and look at what's on these, but you don't need to necessarily worry about them unless they have a warning by them. And if there's a warning by them, that means that something has gone wrong internally, probably not something that you did, and that you need to call a service technician to come out and resolve the problem. The other thing that is really important to check every single time you run the instrument is vacuum status. And so as long as you have a green light here, you're good to go. And so you can see that our status is okay. The high vac is enabled. We have standard pressure for our pressure control, and then we have 3 separate vacuums. So we have a 4 vacuum that's run by the 4 pump, which is a vacuum unit that's separate to the instrument that sits in the back, which we'll go through that as well when we start going through the instrument. This should always be around 2e to the 0. And in the booklet that is by the mass spec, there are what the installation values for the vacuum status were. And so that's kind of a good bench point of where your vacuum should be. And if it changes significantly from this, again, there's a problem and you should probably call a technician to come out. The high vacuum is turned off right now, and that's fine. So the high vacuum only comes on occasionally, and you don't necessarily need to worry about that. The one that is extremely important is the ultra high vacuum. And the ultra high vacuum needs to be below at least e to the negative 10, preferably e to the negative 11, and our installation values were somewhere around e to the negative 12. So we want to have really high vacuum set up so that the instrument works properly. If there's something wrong with the vacuum, one of the things you can do is a bakeout, which we'll go through in just a second, which allows you to reset that vacuum. But again, if the gas hasn't gone off and you're losing vacuum, that means that there's something going on in the instrument, and you should probably call a service technician to come out. Kind of the last 2 parts before we get over to what these other tabs do is you can see right here there's this messages board, which I already kind of talked about. And this messages board tells you everything that has been going on with the instrument. And so the last time I closed this, I don't think it has a date on here, was probably a couple of months ago. And you can see that it was doing a bunch of acquisitions. So information was sent to the instrument, and acquisition was started, then it ended, and then repeated, right? If you have something that's wrong with the instrument, so I think there was like an error warning message somewhere down here, this will show up in your instrument log. So I was trying to calibrate the machine, and it wasn't finding one of the peaks. And so there was an error. It told me that, and that the calibration failed, and then I had to basically keep trying, okay? So if something goes wrong, it's going to be in this messages log. There's also this tab to do the analysis graphs, and so this will plot data. This is from the last calibration, so it was plotting our calibration for our mass accuracy. All of that is going to be saved in these calibration reports. So if you go to latest, it'll tell you what the various parameters are. You can see that graph is there, and then it will tell you what your calibration history trend was. So it was high, and then it dropped and started coming back up. And so all of this is stored on the machine. So as I was saying before, one of the things that's important for just kind of checking your spray and seeing if things are working is this total ion current. And under this mass traces tab, you can actually plot. So if you see how it says here, just plot, how many ions are being sent into the instrument at any given time. And so it's kind of hard to see here, but you have your TIC, which are these red dots, and then what the actual maximum was, and it's gonna plot my ion signal. Right now, I don't know what it's spraying into the machine. It's definitely not the calibration mix, which we'll try to get to come in just a second. But you can see that there's some variation in the spray, but for the most part, it's really stable. What you don't want to see is large spikes and large drop-offs, because that means that you're losing signal. So you again want to keep this TIC variation under about 10%. So right now something is happening and it's shooting some crap into the instrument that it shouldn't be. But you can let this just plot and you can look at over time. So you have your scan number. We're only up to 100 right now. So before I run an instrument, or especially after I change anything on the LC, I'll let buffers run through the column, spraying into the machine, and I'll just watch this spray and see how it acts over 5 minutes or so. So it tells you if your column's equilibrating, and if you have any leaks or anything in there. You would see it because you would see dropout or clogs. You would see big spikes in this total ion signal. So that's something that's useful. You will never need to use these other things. So this is scanning the collision energy. This is the normalized collision energy, and this is the in-source collisional energy, which are looking at parameters of the MS2, and that's something that's going to be way out of the scope of what you're doing. So the just plot feature for the TIC is basically the only thing you'll really need in here. Under this next tab, we have the ability to calibrate the instrument. So this is something that we use regularly. And so if this were spraying actual CalMix into the instrument, this CalMix has been sitting in the syringe for a long time because we've been on quarantine and the instrument hasn't been used. But the most common calibration that we do is this isolation and mass resolution calibration. And so under this tab, you can see that there's a mass calibration that's positive. This is the one that we do every week. About once a month, you should calibrate the negative calibration, or maybe a little bit longer. And then occasionally we'll use these calibrations, especially if the instrument has been shut down, to just make sure everything is working properly. And if you are doing any of those, you will probably be being advised by one of the technicians at Thermo on how to actually do that. You can't really mess up the instrument, but if you get the calibrations off because you're calibrating things that don't need to be calibrated, or when the instrument's not operating optimally, you're basically just going to be decreasing your performance. And so don't touch anything if you don't need to. Another thing that's really important, at least in terms of figuring out the status of the instrument and how like clean the quad is and all of that, is in this evaluation mode. And so you have a positive ion evaluation. This you should probably do maybe like once a month. I think there's guidelines that come with the instrument to look at your isolation mass and the mass check. And this is basically just seeing that like things are lining up and kind of following how they normally are. The other thing that is really important in this, which it's not good to calibrate or evaluate the electronics a lot, because the more you do it, again, the more you cause things to kind of drift off. But an important thing to do, especially either before a run or after a long run, is this isolation transmission endurance test. And this tells you how clean your quad is. And so to run this, you'll have to put CalMix on. The whole procedure takes about an hour. And basically it goes through and it tests multiple different parameters of the quad. If this transmission score is below 0.8, so 80%, that means your quad's dirty and you need to have them come out and clean it. If it's not above 0.9, you probably don't want to run your samples. Sometimes it takes running this a couple of times to actually get a reliable score or like a consistent score. But you can see we had our quad cleaned a couple months ago. I ran the isolation transmission test to make sure it actually got cleaned, and it's 96%, which means that there's very little stuff in there and our ions are basically just being shot in. the last part of this is our vacuum and bakeout. So again, you can look at your vacuum status. This tab is used after the instrument is set to off. So when you break vacuum, you need to reestablish vacuum. And to do that, you need to do what's called a bakeout. And typically a bakeout, if it's been off for any appreciable amount of time, you want to do a 16-hour bakeout or at least a 12. Again, the technicians can tell you how long to do this, but basically you're going to turn the instrument back on and have it reset vacuum, which takes however long you set, plus like 4 or 5 hours for the instrument to cool down and kind of re-equilibrate. And then you need to go through and like check to make sure that everything's functioning properly. So again, as like a normal user just running samples, you shouldn't have to use this, but if you have kind of a more advanced role and you're taking care of the instrument, this will be important. So that's kind of an overview of this. Just really quickly, we'll have another video on actually calibrating. Oops, I didn't hit this fast enough. The instrument, but as I start to inject more stuff in, hopefully what will happen is you can actually see what, so if you look right now on my TIC, because I increased how much is being shot in, I had an increase in signal and then it kind of dropped off. This right here, for the most part, is what the cal mix should look like. And so the reason that we have this drop is we're no longer getting crap that's being sprayed in, which even could be coming from the aux gas or just in that chamber, is we're getting a much lower but more stable signal that's coming from our actual sample. And so you still have about 1 million ions per second that are being shot in. And we're seeing something that's more representative of what our cal mix should look like. So we will continue in the next video talking about Excalibur and operation of the LC pumps and the LC itself, but in just a manual control of the tunes, you can see right here we lost signal. So there's probably clogs and a bunch of stuff in the line that's connecting the syringe pump to the instrument, and our signal comes back. So I have to stop that. This is kind of what you're using if you're just checking instrument status or getting things ready before a run, but those are the different components of it.